Our first question for the review sheet is complete the table of values for the quadratic relation below. Graph the relation on the grid provided. So our trinomial equation is y equals x squared minus 2x minus 3. We're given these x values to plug into the equation. As we do that, we get a y value for each one. So now we have a coordinate pair. When we plot these on the graph, our coordinates look like this. And then in question B, we're asked, how can you tell this is a quadratic equation from the equation and graph? Well, we can tell from the equation because we have an x squared value right here. And we can certainly tell from the graph because we've got that classic parabola look. So we can say equation has x squared and a graph is a parabola. Question 2, determine the characteristics of the following quadratic relation. So we're asked the coordinates of the vertex. So we can simply look at the graph here and see that it falls on the point 5, -8. Our vertex is right here, and we know that our axis of symmetry passes right through the vertex. So we can say that our axis of symmetry is x equals 5. Our y-intercept is right here. Falls on the point 0,4. Here are our x-intercepts, 1 and 9. And the parabola opens up. The path of an arc of water from a fire hose is shown in the graph below. Use the graph of the relation to answer each of the following questions. So A, what is the maximum height of the arc of water? We simply look here at the vertex. You can see that the height is 4 meters. B, what is the height of the arc 3 meters from the nozzle? Well, we just go count over 1, 2, 3, and then we go up and we read off the height here, which is about 3.25 meters. How far from the nozzle does the water land? Well, the water lands when the height is 0, and this happens at about the 4.25 mark. Question D asks, how high is the nozzle off the ground? Well, it's approximately 1 meter. Cassandra's science project involves measuring the distance that a toy rocket travels through the air after it is launched. The table shows the height and horizontal distance of the rocket. So we're asked to graph the data below. And when we plot all our points and join them, this is what our graph looks like. Question B asks, what is the maximum height of the rocket? So we simply go to the vertex right here, and we can see that the height is 45 meters. Next question, at what horizontal distance does the rocket reach its maximum height? Well, the maximum height is right here, and the horizontal distance is 15. How far does the rocket travel before it hits the ground? Well, it hits the ground at this point right here, and it's traveled 30 meters horizontally. Graph the following parabolas using the key features. y equals x squared minus 2x minus 3. The y-intercept is right here at negative 3. The x-intercepts are at negative 1 and 3. The axis of symmetry is right here. And our vertex is 1, negative 4. Now, we can see these points by looking at the graph, but we can also calculate them just using our equation. So the y-intercept is negative 3 simply because it's the c value. We can get our x-intercepts by factoring this. What are a pair of numbers that multiply to negative 3 and add to negative 2? That just happens to be 1 and negative 3. So if our factored form is 1 and negative 3, then our intercepts are negative 1 and positive 3. Once we know our intercepts, we can add them together and divide by 2 to get our axis of symmetry. And once we know the axis of symmetry, then we have the x value for our vertex. So if we take that 1 and plug it back into the equation, I can calculate the y value of the vertex. And that turns out to be negative 4. So our vertex is going to be 1, negative 4. Y equals negative x squared minus 6x minus 5. Well, we want the we want the y-intercept, and that's simply going to be negative 5. Now, in order to figure out the x-intercepts, we need to factor this. But this negative right here is a bit of a problem for us. So we could change this by using the greatest common factor method. So greatest common factor for all the terms in this statement is negative 1. So using negative 1 or negative as a greatest common factor, we can refactor this and get rid of the negative in front of the x squared. And then we're left with positive 1 and positive 5, which makes our x-intercepts negative 1 and negative 5. We add our x-intercepts together and divide by 2. That will give us negative 3. That's our axis of symmetry. Once we have our axis of symmetry, then we have the x value for our vertex. So we'll plug this value, negative 3, into the original equation and get our y value for the vertex. So our vertex ends up being negative 3, 4.